All right, so we filled out the top piece of this. Now it's on to all the good stuff. So there are a lot of things to remember going on here. For one thing, alpha and our confidence level are complements, meaning they add up to 1. This piece is the interpretation piece. There's not much to say about it other than to add that we want context. So you put your C level in here, right? We are blah % confident that the true population parameter is between the lower and upper confidence interval limits. This piece needs to be written with context. The parameter itself could be P, it could be mu, it could be P1 minus P2, it could be mu D, or it could be mu1 minus mu2, right? So you could be talking about a proportion, a difference in proportions, a mean, a difference in means, a mean for the differences. So there's a lot of different things you could be saying. Now, confidence intervals always follow a very basic formula that we want to always keep in mind. And it comes out of the fact, well, the picture of what a confidence interval looks like. So a confidence interval is the point estimate plus or minus the margin of error. And that will get us our lower number and our upper number, which is what a confidence interval is. So if we take our center, if we think of the picture here, you have your lower number over here, you have your upper number over here. The confidence interval is the whole zone between the two. This is the point estimate in the middle, and these two sides are your errors. Which actually leads me to another set of formulas that we've learned, and I didn't leave space for them in here, so I'm going to add them. So I'll put them down here. I'm going to leave myself some space. So point estimate, if you have the interval, is the lower plus the upper divided by 2. And then, actually I'm going to put my box around the whole thing. And then the margin of error is the upper minus the lower divided by 2. Error I'm abbreviating with a capital E there. We've run into those formulas several times. You can only use if you have the interval. If the interval is not known, you can't use them. But if the interval is known, then you can use them. All right, let's see what else. So we've got this picture in our heads for the way a confidence interval works. Let's look one more time at the margin of error and the width. So the error is the distance from, if you will, here to here. That's the error, or here to here. That's the error. And there's relationships that we've learned between that error, and essentially the error is the width, right? So two of them make the width. So the sample size and margin of error have an inverse relationship. Matter of fact, that one's so key, I'm going to put it in a different color because that's the different one. I'll do all these in a different color. This is a direct relationship, and this is a direct relationship. So what does an inverse relationship mean? It means that if sample size, which remember sample size, the symbol for sample size is n, and this is error, right? This is C level, and this is error, and this is standard deviation S, right? So if n goes up, error goes down. That's an inverse relationship. I'm going to put my n in pink too, just to make it obvious. Or if n goes down, error goes up. Direct relationship means that if C level goes down, error goes down, or if sea level goes up, error goes up. And same with the standard deviation. If S goes down, error goes down, or if S goes up, error goes up. This leads me, these three relationship pieces lead me to one other thing, which is that I usually don't ask the questions, and your professor probably won't either, about whether your error is going up or down. Because error is the width of the interval. So what we think about is the narrowness, wideness of that interval. So I'm going to add a note down here. If the interval is narrower, that means that the error is smaller. Now, error is smaller when either the n goes up, the sea level goes down, or the standard deviation goes down, right? And the interval is wider, right? Wider means it's more spread out, which means my error is larger. And that happens, error is larger when n goes down because they have an inverse relationship, but sea level goes up. Level goes up, or standard deviation goes up. All right, last piece. And this is something specifically from chapter 11 that we've learned, which is that when you have your interval, your lower to upper here, if 0 is in the interval, that means there is not a significant difference. And if 0 is not in the interval, that implies that there is a significant difference. And if you're thinking difference in what, well, it would be difference in proportions, or difference, the mean of the differences, or the difference in the means. Right? So it depends. So for our purposes, we'll just say when there are zeros not in the interval, there is a significant difference. And when 0 is in the interval, that means there is not a significant difference. Between the proportions of the two groups, or between the means of the two groups, or whatever you are discussing. But again, that's only for chapter 11 when you're talking about the difference between two groups.